This video will look at applying the binomial distribution to solve problems, and to do that we'll look at example 9 and then extend it to example 11. Alright, we want to find the probability that when you flip a coin 12 times you will get exactly 8 heads. Alright, for example 9, first thing to do is we want to identify, is it a binomial? So when you look at this, I'm flipping a coin, do I get heads? True or false, success, failure. That can be boiled down to two things. We know how many times we're going to run the experiment, 12. Each trial is independent, and the probability stays the same in each time. So we can run through this and look at it and say, okay, binomial, n is how many times we're going to do it, 12. X, how many successes are we looking for? Well, what's the probability we get 8 heads? And then P, probability of success on any given trial. Well, you flip a coin, probability of heads is 0.5. Now, you can use the table in the back of the book. And if you do that, you go to the band of rows equivalent to n equals 12. Go down to the row x equals 8 within that band and find the column probability equals 0.5, and where those intersect you should see 0.121. Alternatively, you could run it through the formula, plug in the 12 for the n, 8 for the x, 1/2 or 0.5 for the p, 1/2 or 0.5 for the q. I did this all in fractions. Again, if you would rather go to decimals immediately, that's fine. And you end up with 0.121 here. Also, you could use the formula in Excel, the binom.dist formula, and that should give you the same result. All right, so that's a basic case with the binomial. Example 11 is similar, but a little bit extended. Okay, we're flipping a coin again. When flipping a coin 8 times, find the probability of getting at least 6 heads. Okay, so the difference here is that at least phrase. In example 9, we were looking for exactly 8 heads. Example 11, we're looking at least 6 heads. All right, so let me get it down to example 11 here. Okay, so once again, first thing you would do is determine, yes, this is a binomial, and the process for that would be exactly the same as what we went through with example 9. So the next thing to realize is the probability of at least 6 heads is the probability of 6 heads plus the probability of 7 heads plus the probability of 8 heads. So this is going back to the stuff we had done in chapter 4, realizing that when you have probability of 6 heads or 7 heads or 8 heads, you need to add those probabilities together. Okay, so looking at this as a binomial, our n is 8. We're flipping the coin 8 times. Our p is 0.5. Probability of getting heads on any given flip is 0.5. Now what's interesting here is our x, we're going to have 3 different x values. We're going to do this 3 times. We're going to do it for 6, for 7, and for 8. So again, you could use the table in the back of the book. Go to the band of rows matching up to n equals 8. Find row 6 within that. Go to column 0.5, and you should see 0.109 where that intersects. Drop down 1 row for x equals 7, 0.031. Drop down to the final row in that section, should see 0.004. So the probability of at least 6 is the sum of those 3. If you add those together, it's 0.144 or 14.4%.